interface brief here on router 1, you'll see that our IP address is 10.10.10.1. If we jump over to router 2, we are at 10.10.10.2. So first thing on router 1, from global configuration mode, let's configure our ISAKMP policy. And we do that with a command, crypto ISAKMP policy. And if we look at contextual help, you'll see that these can be numbered 1 through 10,000. And this is just giving that a policy number. So I'm just going to start with policy number 1 here. And if we hit enter, and then we take a look at our help options, these are our policy options. These should look familiar. Remember the Hagel mnemonic that we talked about? We see all of those values here. Hash, authentication, group, lifetime, and encryption. So let's just go ahead and start right at the top. We'll start with authentication, and we'll just go right down our list. If we look at contextual help, you'll see that we can choose pre-share, RSA encryption, and RSA signature. So if we choose the RSA signature option here at the bottom, we'll need a certificate authority connected. The RSA encryption option uses RSA public key exchange. In this case, we want to set up our own pre-shared key, so we're just going to use the pre-share keyword. And if we look at contextual help, you'll see that that is actually the end of this command. So even though we've determined we're going to use pre-shared keys, we're not setting that key up just yet. That will be done outside of our policy at a later time. So we'll hit enter. And the next thing, we can say encryption. And if we look at the options there, we have triple DES, AES, and DES. Now, DES and triple DES, of course, are considered to be legacy algorithms, so AES is the chosen successor due to the larger and more secure key length. So we want to say AES, and you'll see that we can choose the number of bits in the key. This value is critical that we match on both sides of the tunnel. We want to remember that, so I'm going to set that to 256. Next, we can say group, and take a look at those options. Lots of options here. The group, of course, refers to the Diffie-Hellman group. Remember, the Diffie-Hellman protocol makes a secure key exchange possible over a non-secure channel. And just some notes from Cisco's documentation, they currently recommend using at least 2048 bits, which you can see is group 14 near the top. So I'm going to choose group 14 as well. We'll hit enter. And next is hash. And if we look at the options here, we're going to see a few legacy algorithms, namely MD5 and SHA-1. We want to choose something from the SHA-2 family, that being SHA-256, SHA-384, or SHA-512. So I'm just going to go with the highest option, and I'm going to say SHA-512 here. And finally, we want to set the lifetime value, and this is the lifetime for the ISAKMP Security Association. Remember, we're actually building two security associations. First, we create the ISAKMP Security Association. Then later, we're going to create the IPsec Security Association. So this lifetime value is for the ISAKMP SA, or in other words, IKE Phase 1. So if we look at the options here, we can see that this lifetime value is in seconds. So if we want this to be, let's say, 60 minutes or an hour, then we would set this to 3,600 seconds. Let's hit enter, and we'll break out, and we'll take a look at everything. We can see that policy by saying show crypto ISAKMP policy, and we can see all of our details here. All of the values for our Phase 1 policy are in place. We see our encryption algorithm as AES, our hash algorithm, SHA-2, 512 bits. All of the things we would expect to see are listed here. Now we need to mirror this policy on router 2, so let's jump over there and do that as well. Under global configuration mode, crypto ISAKMP policy 1, we'll say hash, that was SHA-512. Authentication, we're using the pre-share method. Group was group number 14. Lifetime, 3,600 seconds. Encryption, AES, 256. Let's break out, and we'll say show crypto ISAKMP policy. And again, we can see a confirmation of everything that we've configured here. So that matches on router 1. Let's go back over to router 1 now. And now we can set up our pre-shared keys on each side. So let's go back under global configuration mode. And we could say crypto ISAKMP. And this time, instead of policy, we want to say key. Let's look at our options under here. You can see that we can set an unencrypted or an encrypted password. So I'm going to use the option 6 for an encrypted password, and help's going to indicate that we can now set our password. I'm just going to set that very simply to Cisco. The next option, we need to put in the IP address of router 2. So in that case, I'll say address, and that is 10.10.10.2. I'll hit enter, and that's it. Let's jump over to router 2. Go under global configuration mode, and we're going to do the same thing here. Crypto ISAKMP key 6 for an encrypted key that was set to Cisco on the other side. We want to say our peer address is 10.10.10.1. So we'll hit enter there. Next thing we need to do is we want to create the IPsec transform sets. And if we go back to router 1, the command for that is crypto IPsec instead of ISAKMP, because now we're working on the IPsec SA, and we can look at our options, and the one that jumps out is transform-set. That's the one we want. You can see that we can give that a name. I'm just going to call that remote in all caps. And then the options, we have lots and lots of options here. We have to define one method for encryption and one method for authentication. We have the authentication header options at the top. You can see those with the AH at the beginning, meaning authentication header. If you remember, authentication header only authenticates and does not offer encryption. So this is not suggested. We would want to go with ESP, encapsulating security payload. In this case, I'm going to say ESP AES using that stronger encryption method. And then you'll see at the top, we can set the bits once again. I'm going to set that to 256. And next, we want to set our authentication method. For that, we're going to use ESP SHA-512-HMAC. And once we hit enter there, you'll see that now our configuration mode has changed. We're now into transform set configuration mode. So let's look at the options here. And the option that I'm interested in is mode. If we look at our help options, we have two possible modes. Remember, we have transport mode and we have tunnel mode. Here I'm going to say transport and hit enter. Now we can break out and we can say show crypto IPsec transform-set, and we can see our newly created transform set here with all the details. Now again, we want to mirror that on the other router. Let's go to router 2. We're already under global configuration mode. So we'll say crypto IPsec transform-set. We'll call that remote ESP AES 256, and we'll say ESP SHA-512-HMAC. We'll hit enter to take us under transform set configuration mode, where we can say mode transport. We'll hit enter there. And that's it. The IPsec SA is now established and phase 2 is complete. So let's break out. And from this side, let's also say show crypto IPsec transform-set, just to verify that all looks good. And one more thing we need to do is to create a crypto map. What a crypto map does is simply define which traffic should be protected by IPsec, where that protected traffic should be sent, and which IPsec transform sets should be applied to the traffic. So I'm going to go back to router 1, and I'm going to run the command show access -list. If we take a look at that, you can see that I have a very simple access control list in here. Access control list number 101, simply allowing traffic between these two routers. And I have the exact same thing happening on router 2. So we can begin our crypto map. By the way, we need an access control list for this crypto map. That's why I wanted to show you that. So let's go under global configuration mode. And let's start with the command crypto map. You'll see that we can give that map a name. I'm just going to use map in all caps. And we need to give that a sequence number. I'm just going to use sequence number 1. And under those options, we want to choose IPsec-ISAKMP. And when I hit enter here, we're going to get a note letting us know that this crypto map will not work until an access control list and a peer have been defined. Again, that's why I wanted to show you the access control list, so we can acknowledge that, and then that's what we'll do. We're under crypto map configuration mode now, so we can use the command match, and you can see we can use the address option, followed by the access control list number, which is of course 101 in my case, and that's it. So now traffic that matches ACL 101 is going to be affected. So now we need to set the transform set and the peer. So let's say set, and we'll look at our options. And of course, transform set is the first one that we will use. And notice our contextual help is going to tell us we can list numerous transform sets in priority order. In our case, we only have one that we're going to use, which is of course called remote. And we'll also want to set a peer address as well by saying set, and we'll use the peer option. And the options are going to tell us we can use an IP address, which is of course what we want to do. So I'll set that to 10.10.10.2, which is router 2. And finally, just like with ACLs, you have to apply a crypto map to an interface. So let's go under interface gig 0/0 in this case, which is the interface connecting us to R2. And we'll say crypto map. The name of that is map in all caps. And we'll hit enter. Now if we break out and say show crypto map, this verifies all of our configuration. We can see our peer at 10.10.10.2. We can see our access list 101. We can see that statement. We can see our security association lifetime, 3,600 seconds. We can see information about our transform sets, which interfaces are using the crypto map. So all of that looks good. Again, we need to do the same thing on router 2. So let's jump over there. Under global configuration mode, crypto map, I'm going to call that map. Sequence number 1. I want to say IPsec, ISAKMP. We'll hit enter, and again, we can acknowledge that note. We'll use the match address command for 101, the ACL. We'll say set transform -set. The name of that is remote. We'll set our peer to 10.10.10.1, which is router 1. We'll go under interface gig 0/0, which connects us over to router 1. And we'll say crypto map, and the name of that is map in all caps. So let's break out of here. Let's make sure that we can ping router 1 first, 10.10.10.1. And now we see that we are successful with that ping, so that's good. Took a little bit of time to resolve, but eventually we did get successful pings happening. One more time just to be sure. Now let's say show crypto ISAKMP SA. And we can see that that looks good. We see that we are in the idle state listed here. And that means that this tunnel is up and the IKE SA key exchange was successful and the tunnel is active. So that's great. We can also say show crypto IPsec SA. And this is going to show us our IPsec counters. You can see those listed here. We can see the number of packets being counted. So this proves that we are getting traffic over our VPN connection. So that's a look at configuring a site-to-site VPN.